Hello again, this is Professor Jim Caffey, and today we are going to do Chapter 28 in the OpenStax free astronomy textbook. Chapter 28 is on the evolution and distribution of galaxies. And what I want to do here is to show you a bunch of really beautiful, neat images we have of deep space and talk a little bit about that. So, with that, let's get started on Chapter 28. So I'm going to show you some pictures, and these are colliding galaxies. And when galaxies collide, they're so big they don't collide like cars on a road do. They really go through each other and just distort all the structure from the gravity being messed with. When we look farther back into space, we see farther back in time. We have seen some galaxies that are 13 billion light years away. Now, what does that mean? Well, we estimate the age of the observable universe as of 2019. It is 13.8 billion years old. 13.8 billion years old for the age of the universe. This galaxy is at 13.2 billion, and what that means is we're seeing that galaxy when it was born, right after the universe was born. Really neat. And we say that these things at such far distances away, 13 billion light years, we say that has a very large galactic redshift. Remember, redshifts, the object moving further away from you. When we talk about galactic speeds, a fraction of the speed of light, then we talk about a galactic redshift. This is the Hubble Ultra Deep Field. They did a original deep field in the 1990s, and this one is even better. Every single smudge dot image on this mosaic is a galaxy with billions of stars. We have seen early galaxies with Hubble. We have seen the faintest, farthest, smallest galaxies ever. We see galaxies interacting and colliding with each other. We can model this collision process in computers pretty accurately too. Sometimes when galaxies collide, one galaxy doesn't make it. The stronger one survives. When you have these galaxies colliding, remember what you need to have for star formation. We need gas and dust. So when you introduce some new gas and dust into a galaxy, you get lots of new hot stars being formed. We can see collisions in clusters of galaxies billions of light years away. Here is a beautiful galaxy, Centaurus A, in the southern hemisphere. Here is Edwin Hubble, born just a few miles from me in Springfield, Missouri. Edwin Hubble was born in Marshfield, Missouri. He has some schools, interstate named after him, and there is a 1/3 scale model of the Hubble Space Telescope on the county square. It's a very small town. So here is Dr. Hubble at the 100-inch telescope at Mount Wilson. They give tours now out at Mount Wilson. I know some of the docents that give those tours, and they are doing great work out there. If you ever get out to California to go visit one of those observatories, go down to Tucson to Kitt Peak National Observatory. They do a lot of great outreach. We have about 24 galaxies in what we call the local group, our neighborhood of the universe. My city, if you want to call it that. And there's about 24, the two biggest ones being ours, the Milky Way, and the Andromeda Galaxy. Another cluster of galaxies is in the constellation Virgo, which some of you may have seen now. And this is 50 million light years away. And this is just an ensemble of clusters of galaxies, hundreds and hundreds of galaxies clustered together by gravity. I did some work at Kitt Peak on the Virgo cluster of galaxies in 1996. The central region of the Coma cluster, seen from the Sloan Digital Sky Survey. I had some work done in that, and the Spitzer Space Telescope is an infrared telescope. I have a colleague on that. If you have an object billions of light years away, like a quasar, but you don't know it's there because there's this massive galaxy in the way, we can't see it. Actually, Einstein predicted, and we have verified this to be true, that the light from that quasar is going to bend around the gravity of that galaxy and get back to us on Earth, believe it or not. And let me show you what that looks like in our images. Here is a supernova going off behind this galaxy, but it's being bent around that galaxy. And so it arcs off into different arcs. Sometimes with these, they call them gravitational lenses, lenses that light into a gravity focal point. Sometimes you get arcs instead of points. So here are some arcs that we have seen. And here is Margaret Geller, who did a lot of work mapping these galaxies and researching them. Amazing astronomer. The Sloan Digital Sky Survey that I had done some work with for about a year is mapping the large-scale superstructure of the universe. So hang with me on a minute here and listen. We have seen in the universe that is 13.8 billion light years across. We can see structure on the microscopic scale, in cells, in DNA, in a biology class. In astronomy, we see the other extreme, the most distant, the biggest, and the best. And I can tell you this thought. We see large-scale structures spanning billions of light years throughout the universe. There are bubbles, and galaxies are on the edge of the bubble, and clusters of galaxies. And in the middle, there are voids, where there's virtually nothing there. If the universe, the Big Bang, was an explosion of sorts, a rapid expansion of space and time itself, how do we get structure of billions of superclusters of galaxies going 10 billion light years across the universe? We call it the Great Wall, the Great Attractor, and the universe has scale on the largest possible. Just let that sink in. Here is the Sloan Digital Sky Survey. Really neat, highly automated instrument. Here's some more lensing gravities with clusters of galaxies. X-ray imager one. The large and small Magellanic clouds, we have seen these a lot, and they are in the southern hemisphere. We can see merging clusters and merging galaxies in clusters far, far away. And here is that large-scale structure that I said we have seen. In these supercomputers, here's what we see. We see a homogeneous mixture here at the Big Bang, and now we see this superstructure. Can you see the bubbles and the voids and this 10 billion light year long structure? And we got that from the Big Bang. Yeah? Well, I'll leave you with that thought about superclusters and 10 billion light year long walls of clusters of galaxies and large scale structure in the universe. I want you to think about what that means and how we got there. I'll see you next time. Well, did you enjoy that episode of 10-Minute Astronomy? If so, check out all the other videos in that playlist for 10-Minute Astronomy and other videos on my channel, and then hit the subscribe button right there. Thanks.